So we left with DRDW. This is kind of our beyond accuracy algorithm. And what Informfully Recommenders is our way to put beyond accuracy models or beyond accuracy experiments into practice. So what you see here on the screen is basically the list of reproducibility frameworks that RecSys recommends you to use or advises you to use. There is a slight issue if you don't focus on accuracy. So if you look at beyond accuracy metrics, evaluation objectives, etc., one thing you might want to do is look at user satisfaction, user happiness. And for that, you might want to actually do some online experiments. But online experiments, exposing the recommendations to actual users, this is not really part of kind of what many of the recommended frameworks actually do. So you see CORNEC, which is kind of the basis that Informfully Recommenders is based on. They actually support it, but all the others, they kind of ignore that users actually interact with your system. If you look at beyond accuracy metrics or models, algorithms, you also see that most of the times, the beyond accuracy part, for example, if you look at diversity, it's kind of an afterthought. So you first have a model, it does its job, then you have kind of a diversity re-ranker, for example, it's mushed together and then shared with the research community, with industry experts and so on. But this kind of makes it really hard to kind of entangle. So ideally, you want to have the model and re-rankers separated, and kind of the support for those model and re-ranker separations also is not really offered by many of the available frameworks. One thing that many frameworks do support, however, are beyond accuracy metrics like diversity, serendipity, and so forth. But most of them do not offer all the necessary scripts to do the data augmentation to calculate all those metrics. Also, a user feedback loop. Most of the times, the kind of implicit assumption is your reproducibility framework looks at the user, creates a set of recommendations. Then you take those recommendations, you assess them based on a certain set of metrics. That's the end of the story. But most of the times, there is actually a kind of back and forward. I mean, in practice, users receive recommendations, for example, news. They read them, they like them, they give you valuable feedback. And this feedback you could, in theory, take again into consideration when you process the next batch of iterations. Fortunately, this kind of feedback loop is hardly supported by frameworks. Also, item visualization. So we know from research that the impact of how you visualize item is actually quite a large and significant impact. Whether, I mean, displaying a news item prominent on the very top of your feed boosts the click rate enormously versus it being kind of buried somewhere at the bottom. But those considerations regarding visualization are also not really kind of part of any, or most of the current frameworks don't really support it. So our idea with Informfully Recommenders is to have kind of an end-to-end pipeline that really supports everything that you as someone who wants to look at beyond accuracy metrics or objective really needs. And for that, we have a 4-stage pipeline. So in the first stage, and I'm going to highlight what is relevant for the news track, we have support for the main data sets that the news recommendation community uses, such as EBNERD and MIND, where you can easily load everything in. We have data augmentation functionalities to make sure that all the beyond accuracy metrics we provide, you have the scripts to create the data. For example, I don't know, if you look at politics, you have scripts to annotate politicians, parties, and so forth. In terms of in-processing, so we offer a bunch of data splitting methods. most of the time people do random splitting, but sometimes it's not really interesting. If you look at diversity and what, for example, impacts diversity, maybe you sometimes want to have specific attributes that should serve as a guideline for how to split the data. Maybe you want the stratified data splitting, etc. So those are all kind of different ways that we offer out of the box for you to choose to kind of really see how the input into a model reflects in its output. Then, of course, in terms of model selection, so we have a bunch of in-house models that we put into the framework. The previously presented DRDW being just one of them. Also, we introduce a post-processing stage where you can play around with different re-rankers. A couple of our in-house models we have also in the flavor of a re-ranker that you can simply attach on top of your existing model. So, for example, you can have DRDW as a lightweight re-ranker for whatever model you have in-house. Also, we then have a kind of a user simulator with 2 user models. So if you are interested to look how this feedback loop, or if you want to simulate a feedback loop, we have a model that you can say, okay, let's assume we have a user that only clicks on the top item, or let's assume we have a user that only follows their preferences. So this is something you can really play around with. Finally, in the evaluation stage, again, we have a couple of beyond accuracy metrics and everything that you can then assess the output of your recommender system. And finally, we have a nifty script that takes the recommendations that you have and forwards it to our front end where you can actually expose users to your recommendations. So again, the goal was to provide you a kind of a pipeline that you can mix and combine. What is shown on screen is how your recommender system or the output could look like if you use our backend and front end. But of course, it's completely up to you what elements you want to use. If you're already using CoreNet, you're good to go. You can download our code and get started right away. Every of the stages I presented can be used individually or in combination. And with almost a flick of a switch, you can turn your offline reproducibility pipeline into an online experiment where you can actually get user feedback. And with that, here is, again, download code and everything. Everything is open source for you to play around with. Join us on GitHub. Make your pull requests. We're happy to interact and get feedback. Thank you.
Like, is it click and play? Like, if I have an offline evaluation and I want to turn it into an online evaluation, like, how many steps do I need? Like, how cumbersome is it? What is actually needed?
Yes. So the main things needed are basically you replacing your offline data set with a kind of a database. So you just pipe in a different data set. You remove, of course, the user simulator and have the actual user feedback. And then you either already have installed our front end, or you just, once you set this up, you then take the output of your recommender system, use our script, it translates it to something that our front end can read, and then you're good to go to set up your study.
Maybe it's a little reformulation of the previous one, but supposing that I would like to create a user study, like different groups of users on top of your system, how many things I would have to implement myself? What's missing there at the moment?
We have kind of a range of different algorithms and re-rankers. So in theory, if what we offer, you can just pick and choose, right? So you don't need to code anything. If you wanna, but of course, you're free to kind of, if you say, oh, I don't like this model, then you have to build the model, right? But if you're happy with what we offer, there's not a lot. You might need some, I don't know, you might need some server infrastructure to run the model, etc. But this is kind of unavoidable.